Welcome to session one of GED Science Mastery. I am really glad you are here and I want you to relax because we are going to build this together, one calm step at a time. Before we learn a single fact about cells or atoms, you deserve to know exactly what you are walking into. So today has two jobs. First, we will look at what the GED Science test actually is. And second, I will hand you the one simple method you will use on every question for the rest of this course. Read the evidence, choose what it supports, and check for traps. Learn this well, and everything after it gets easier. Let's start with the plain shape of the test, so nothing surprises you on test day. You will have about 90 minutes and roughly 34 questions. Your work is scored on a scale from 100 to 200. A score of 145 is a passing score. 165 is the start of the college-ready band. In this course, our target is 160 or higher. That sits safely above passing, and it is knocking on the college-ready door. It is ambitious, but it is completely reachable. Now, what is actually on the test? The questions come from 3 science subjects, and they are not weighted equally. Life science is about 40% of the test. Physical science is also about 40%, and earth and space science makes up the smaller slice, about 20%. So together, life and physical science are about 80% of your score. That tells you where to spend most of your study time. But every subject matters, and we will cover all 3 carefully. Here is the heart of the whole course. Almost every GED science question hands you something to look at: a short passage, a table, a graph, or a diagram, and then asks, what does this actually show? So you will use the same 3 steps every time. Step 1. Read the evidence first, before you even look at the answer choices. Notice the title, the labels, the units, and any trend. Step 2. Choose the answer the evidence supports. A good answer usually stays careful and narrow, not dramatic. Step 3. Check for traps before you lock it in. Does the answer use extreme words, or the wrong units, or say more than the evidence proves? If it does, it is probably wrong. Before we practice, let's own 5 small words, because the test uses them precisely. A claim is the statement someone is making. Evidence is the data or passage detail that backs a claim up. An observation is what you directly see or measure. An inference is a reasonable conclusion you draw from that evidence. It is careful thinking, not a wild guess. And a conclusion is the final judgment, and a good one stays limited to exactly what the evidence shows. Keep this chain in mind. You move from observation to inference to conclusion, and you never claim more than your evidence allows. Let's read a passage built just like the real test. A gardener wanted to know if a plant food helps tomato seedlings grow. She grew 20 seedlings the exact same way. Same pot, same soil, same water, same sunlight. Then she gave plant food to 10 of them, the treated group, and no plant food to the other 10, the control group. After 3 weeks, she measured the average height of each group. The treated group averaged 24 centimeters. The control group averaged 18 centimeters. Look at the 2 bars. There is a real difference here, and in a moment we will decide, carefully, what it does and does not prove. Now watch me solve it with our method, slowly. Read, the gardener changed just one thing, the plant food, and kept everything else the same. Treated averaged 24, control averaged 18, a real 6 centimeter difference. Choose. The answer that stays inside the evidence is, in this test, the seedlings given plant food grew taller on average. Check. I reject. Plant food always makes every plant grow taller, because always and every go far beyond one 3-week test. And I reject the soil caused it because the soil was kept the same. Now, how big was the effect? I use percent difference. Bigger minus smaller over smaller times 100%. That is 24 minus 18 over 18 times 100%, which is 6 over 18. And that comes out to about 33% taller. Let's name the traps now so you can spot them from a mile away. The first trap is extreme words: always, never, all, none, proves, only. Careful science answers almost never need those words. The second trap is the wrong units, an answer that gives a distance when the question asked for a speed. The third is reversed cause and effect, where the choice flips which thing caused which. The fourth is going out of scope, a statement that sounds true, but the passage never actually measured it. When you hit the check step, run down this short list and a lot of tempting wrong answers will fall away. Two last things before you practice. First, pacing. About 90 minutes for about 34 questions is roughly 2.6 minutes per question. That is your budget. If one question eats 5 minutes, make your best guess, flag it, and move on so you can bank the easy points. Second, the recap. GED Science is a reading and thinking test with science inside it. On every question, you read the evidence, you choose what it supports, and you check for traps. Stay inside the evidence, avoid the extreme words, and you are already thinking like a scientist. Wonderful work today. You now know what the GED Science test is, and you have the one method you will use on every single question: read, choose, check. Your practice for this session is the 10 questions attached to this lesson. Answer them from memory, then read every explanation, even for the ones you got right. To read the full lesson notes and practice more GED Science questions, visit the course page at www.bridgetoexam.com. I am proud of you for starting. I will see you in session 2, where we learn to read graphs and tables like a scientist. Keep going. You are doing great.